This call is now being recorded.
Okay. So, yes, in this study lecture, we have started with the chapter number 2. The name of the chapter is the method study. So, as per the earlier discussion, in the yesterday's lecture, we have discussed about the important things related to the method study and how this particular method study plays very important role in order to overall development or overall development of the productivity of that particular organization. So, method study means it is used to eliminate the unnecessary operations. This is the basic use of this particular concept of the method study. And in addition to that, in that particular method study, we are using the various types of the recording techniques, or we are going to apply various types of the recording techniques in order to improve the effectiveness of man, machine, and its system. And in addition to that, as per the British standard, if we are developing the new method for the new product, or sometimes we are doing the modifications in the existing process, but during the development of the new product and during the modification in the existing process, we have to focus on the cost reduction factor also. So that part also we have discussed in the last lecture. Then these are the major objectives we have discussed in the yesterday's lecture, that is, it removes the excessive work content, whatever the additional operations, whatever the additional unnecessary operations are present in the manufacturing process. To remove that particular operations, this method study concept plays very important role. Then it will analyze the operations which is ongoing. If any material is converted, or if any product which is ongoing, means if your raw material is converted into the finished goods, whatever the process is going on, whatever the operations are performing on that particular material, their recording or their data is also analyzed by using this particular method study concept. Also, it develops the better method for doing the operations. Means either we are modification in the existing process, or either we are developing the new method. Then reduce the monotony of the work. Whatever the repetitive movements are taking place, whatever the repetitive work is taking place by that particular man, or repetitive movements of the material is taking place, that can be also reduced by using this particular method study concept. Then fifth one is the material flow within minimum bag. So sometimes what happens, the material is moving from one workstation to the another station, then from second to third, third to fourth. But sometimes again from workstation number 4, again it is coming back to the workstation number 1. That means again that material is moving in the reverse direction. So such types of the unnecessary, whatever the repetitive movement or reverse movements are taking place, that reverse movement also it can be reduced by using the concept of the method. Sometimes the repetitive movements are required as per the requirement of the product, but we have to focus on that particular process through which there should be the minimum bag. Also, this method study concept is used to improve the layout. Why the repetitive operations are taking place? Why the unnecessary operations are developed in the that particular process? Because your layout is not properly designed. If there is a maximum distance in workstation number 1, 2, then from 2 to 3, then that material has to travel maximum distance. Unnecessary, your operation cost or your production time goes on increasing. If you will design your layout in the proper manner, then also there should be the reduction in cost, and there should be the overall development of that particular product. Therefore, for improving the layout also, this method study plays very important role. Now we'll discuss about the scope of the method study. What is the scope of the method study and where this particular concept is to be applicable? So as per the British standard, or as per the various scientists, maybe the F.W. Taylor is there, Gilbert is there, as per his suggestions, this scope of the method study is not applicable only for the manufacturing field. So whatever the industries are there, maybe our mechanical industries are there, in that we are generating the different types of the products. We are using the different types of the operations, different types of the machines, different types of the workers. Some advanced technologies we are using. Means there is one manufacturing sector, only manufacturing field is there. But this concept of this method study is not applicable in only for the manufacturing field, but it is also useful for other service sectors also. Then which are the other service sectors? For example, offices. So whatever the offices are there, maybe some government offices are there, some organizational offices are there, then some banks are there, hospitals, and all other organizations. That means except manufacturing field, except our mechanical industry, some another service sectors are also there in which we can apply the concept of the method study. Means we can apply the concept of method study in the office, we can apply the concept in the bank, then in the hospital, then some all other organization, maybe some training organizations are there, some engineering colleges are there, some hospitals are there. Like them, in all the other organizations, the concept of the method study will be applicable. Then the scope of method study is making the improvement in. So if we will apply this particular concept of the method study, due to which there should be some improvement. In that first one is a manufacturing operations. If I will apply this concept of method study in the manufacturing field, then obviously there is a improvement in the manufacturing operations. Means we can eliminate some unnecessary operations through which you will get the new method. So in the improvement in the manufacturing operations also, your scope of the method study plays very important role. Then work method and the work process. Which types of the work we have to perform, and to perform that particular work, which type of process I have to use. For example, which type of the product I have to manufacture, and in order to manufacture that particular product, which process I have to implement or which process I have to use. That selection, for that particular selection also, this method study plays very important role. Because what happens, one product can be manufactured by using the number of processes, but whatever the number of processes are available, out of that particular process, which process I have to select, that selection also, this concept of method study plays very important role. Then third one is a workman material movement with minimum backtracking. Just now we have discussed. So sometimes the material can be moved in the repetitive operations. Maybe again it is coming from workstation number 4 to 3 to 1. That means the backtracking will be taking place. Also, whatever the workers are there, that workers are also operating on that particular machine, and that worker also taking some of the backtracking. That means he has to come back to the workstation number 1, he has to perform their work. Again, he has to go to the workstation number 2, again 3, again 4, again from workstation number 4, again he has to come back to the workstation number 1. That means whatever this particular backtracking is taking place, that backtracking or that repetitive movements can be also eliminated by using the concept of the method study. Then effective utilization of the tools and the gauges. It is related to the inspection. So once the product is manufactured, or in order to manufacture that particular product, whatever the tools we are using, maybe sometimes we are using the hand drilling machine, sometimes we are using some of the measuring equipment, sometimes we are using the gauges. So whatever that particular tools, gauges are there, utilization of that particular tools and gauges is also taking place in the good manner. That means your workstation is designed. So whatever the tools are present, whatever the gauges are there, we have to provide that particular tools, gauges near to that particular workstation only. For the measurement purpose, for the inspection purpose, for taking that particular gauges, if that worker has to travel the maximum distance, then automatically your production time will be increases. Therefore, whatever the additional equipments are required, whatever the tools are required, whatever the measuring devices are required, all such types of the devices, it should be provided to near to that particular workstation, so that worker can easily handle that particular tools, gauges in the effective manner. Then material handling equipments and way to handle it. So sometimes some small components are there, some heavy duty components are there. In order to handle that particular heavy duty components from one station to the another station, at that time we have to use the material handling equipment. Maybe some cranes are there, some tractors are there, some trolleys are there, maybe chain drive is there, belt drive is there. So such types of the material handling equipments we have to provide in the industry. So due to that material handling devices, we can handle the heavy duty components very easily. Whatever the small components are there, that components can be handled by the operators or some unskilled operators. But if possible, if we provide some material handling equipment, then it should be very easy to handle some heavy duty components as well as some small components are there. And while handling it, how to handle that particular material handling equipment. So such types of the trainings is also provided to that particular workers, because sometimes we have to take the one component from one station to the another station, from another station to the third station. So for that purpose, we require the material handling equipment. But how to handle that particular material handling equipment, what care should be taken, such types of the training, such types of the instructions also it should be given through this particular method study concept. Improve the labor efficiency. The method study concept, if it is implemented in the industry, due to which the labor efficiency also increases. Because what happens, if all the workstations are provided in the proper way, the proper layout should be designed. If all the workstations are provided near to each other, so whatever the labors are there, that labor also can work in the effective manner. Because sometimes 2-3 workstations can be handled by the single worker only. So if he has to finish the workstation number 1, then he will move to the workstation number 2. If he will finish the work from the workstation number 2, again he will go to the workstation number 3. So like that, that labor has to travel some distances. But if we will provide all the workstation near to each other, so that worker can be worked in the effective manner, so their efficiency is also going to increase. Then reduce the monotony. Just now we have discussed whatever the repetitive movements of the job or whatever the repetitive movements of the work is taking place, that monotony in the work is also reduced by using this particular concept of the method study. And important thing is that is point number 8, reduction in the cost by reduction in the cycle time of the operation. At one hand, we are providing the advanced technology in the industry, but at the same time we have to focus on the cost reduction also. We can eliminate some unnecessary operations, we can develop the new method, but at that time, while developing the new method or while doing the modification in the existing process, we have to focus on the cost reduction as well as time reduction also. If we will eliminate the unnecessary operation, automatically whatever your ineffective time is there, that ineffective time is also goes on decreases. But during that, we have to focus on the cost reduction also. Sometimes what happens, we are developing the new method. That method can work in the effective manner, no problem. But to develop that particular method, some maximum amount of cost is required. So while developing the new method, while modification in the existing process, that processes can be modified in the minimum cost. So your operations can be performed in the effective manner and it will be performed in the less cost only. So therefore, the last point is very important, that is reduction in the cost. So these are the 8 scopes of the method study. That means if we apply the concept of method study in the manufacturing field as well as in some another sectors also, for example in offices, banks, hospitals, some technical institutes are there, some technical organizations are there. In all these particular organizations, if we will apply the concept of method study, then there will be the improvement. And where the improvement will be taking place, so these are the total 8 points in that the improvement will be taking place. So this is the scope of the method study. Now, work study procedure. So this procedure we have discussed in the chapter number 1 also. Work study means it is furtherly divided into the 2 types, method study and the work measurement. So from the step number 1 to the step number 4, from the step number 1 to step number 4, these 4 methods are called as a method study. And from the step number 5 to the step number 8, this concept is called as a work measurement. What is meant by the method study? Method study means we have to eliminate the unnecessary operations. So whatever the unnecessary operations we are eliminating from step number 1 to the step number 4. That means in the step number 1, we have to select that method in which we have to go for the changes. We have to select that method in which we have to go for the changes. That means in the first step, your method is selected. Then in the second, we have to record their results. So whatever the method we have selected for the modification, to that particular method, we have to do some recordings. We have to check their previous results. And then after that, we have to go for the examination. So in that particular examination, we can ask some of the questions in the form of why, what, how, why we have to go for the modification, when we have to go for the modification, how modification should be taking place. So such types of the questions will be asked in the step number 3. That means we have to go for the examination. And After that, in the step number 4, we have to develop the new method. That means from the step number 2 and the step number 3, we can eliminate all the unnecessary operations, and in the step number 4, you will get the new and the most economical method. And from step number 1 and from up to the step number 4, whatever the process we are carrying out, that particular concept or that particular process is called as a method study. And from step number 5 to the step number 8, that concept is related to the work measurement. Means after developing the new method or after doing the modification in the existing process, we have to go for the measurement. Whatever the new method is developed, for new method, how much amount of operation time is required? Or if we have done the modification in the existing process, whatever the new method is developed by doing the modification in the existing process, for that new developed method, how much amount of operation time is required? That time can be measured from the step number 5 to the step number 8. That means the time measurement can be carried out from the step number 5 to 8, and the modification in the existing process or the development of the new method, it will be taking place from the step number 1 to the step number 4. So this is the work study procedure. This process is furtherly divided into 2 types. 1 to 4 method study, and 5 to 8 it represents the work measurement. Method study means eliminate the unnecessary operations, and work measurement means eliminate the ineffective time. So this particular procedure, work study procedure, also we have discussed in the chapter number 1, but just once again, just for your understanding, once again it will be provided into the chapter number 2 also, that is work study. So this is the detailed procedure which we have to follow or which we have to implement in the industry in order to develop the new method or while modification in the existing processes also. Okay, so this is the work study procedure. Now we'll move to the important point of this particular chapter number 2, that is recording techniques. So method study is one of the important process in which we are using some of the recording techniques. And already we have discussed, in order to represent the process, for example, if the man is performing some of the operations, if your material is converted from raw material to the finished goods, some of the equipments are doing their job. So all these particular movements are represented in the form of symbolic manner. Because what happens, instead of giving the information in the descriptive manner, because sometimes some unskilled operators are there, some supervisors are also there, those who are unable to read that particular descriptive part. If we will provide some write-up pages, we have to perform this particular task, we have to perform this task, then we have to go for this operation. If I will give all this particular information in the descriptive manner, at that time, that workers, unskilled operators, some of the supervisors are unable to read that particular information. So to avoid such types of the situations, what we will do, we will represent all this particular information, we will represent all that particular operations in the form of symbols, in the form of charts, in the form of diagrams, in the form of models. So through this particular symbols, diagrams, charts, that's unskilled operators, some other operators, some supervisors, they will get the information immediately. So instead of information is represented in the descriptive manner, if I will represent that particular information in the form of symbol, some of the charts, some of the diagrams, some of the models, then that workers can easily understood that what he has to perform now or what he has to do in the future. So for that purpose, in this particular method study, these recording techniques are implemented in this particular syllabus. So which types of the symbols are there, which types of the charts are there, which types of the diagrams are there, which types of the models are there, that we will discuss in the detail. But here some detailed classifications are there, which types of the recording techniques are used in the method study. So the first one, A, which is called as a chart. The chart is one of the recording techniques. The chart is one of the recording techniques which is used in the method study concepts, through which you can get the detailed information of the operations going on the industry, movement taking place by the man, machine, material, movement taking place by the equipment. Then if any worker, if he is doing the number of activities simultaneously, then that number of activities are also represented by this particular chart. Then travel chart means it represents the movement of the worker from one station to the another station, how much distance is traveled by that particular worker or operator. Similarly, how much distance is traveled by that particular material from one station to the another station, from second to third, like that. All these particular movements can be recorded by using this particular charts. Then second is a diagram. Some of the standard diagrams are also there. Through this particular diagram also, we can represent some of the movements taking place by that particular worker and by that particular material also. Then some templates and the models are also there. Models means if we have to give the training to the unskilled operators. So to give that particular training, if we will prepare some of the models, so through that particular models, that supervisor can explain the things in the effective manner, and by observing that particular model, that unskilled operators or that particular operators, he will get the information immediately. So if the models are not present, sometimes that operator has to think in their mind. If the models are not available, then that operators or the skilled operators, he has to assume some of the things in your mind. But instead of that, if we will prepare some of the standard models and through that particular model, if that supervisor give the presentation, then through that particular presentation and through that particular model, that operators can easily understood that now he has to perform this task, now he has to do this particular operations, like that he will get all the types of the information. And the last point is the Therblick Simo chart. The Simo chart is also one of the recording techniques which is used to record the small movements. Some of the micro movements are also taking place. If you take the example of lathe machine is one of the total structure. On the lathe machine, we are performing the so many operations. That means sometimes we are holding the job in the chucks. Then we are taking the tailstock towards that particular job. Then we will fit your tool in that particular tool post. Then that tool post can be moved, maybe in the forward direction, maybe in the backward direction. So like that, all such types of the small movements will be carried out in the same workstation. If I have to perform the job by using the lathe machine, all the movements can be performed on that particular lathe machines only. So whatever the small movements, whatever the micro motions are taking place, all these particular small movements, micro movements, it can be recorded by using that particular Simo charts. So such types of the movements is also recorded by using this particular recording techniques. So these are the 4 recording techniques which we are going to study in this particular chapter. In that first one is a chart. That charts are again subdivided into the 5 types. That is operation process chart, then flow process chart, two-handed process chart, multiple activity chart, and the travel chart. So these are the total 5 charts which we have to study in this particular first type, that is chart. Then diagrams. The diagrams are also divided into the 2 types, flow diagram and the strain diagram. Then we'll discuss about the templates and the models. Which types of the templates are used for recording purpose? Which types of the models we have to use for the demonstration purpose? Then Therblick Simo charts in order to record the micro motions or the micro movements. At the time, this Simo charts plays very important role. So these are the 4 basic recording techniques which we have to study in this particular chapter. And in all these particular recording techniques, all the movements are represented in the form of symbolic manner, in the form of diagrams, so that workers can easily understood that now which operation he has to perform, which inspection he has to go, now which task he has to do. So all these particular movements are represented in the symbolic manner only. So through that particular symbols, that operator, that worker, that supervisor easily understood that which task he has to perform. Okay, so these are the recording techniques which we have to discuss. Instead of giving the information in the descriptive manner, it will be represented in the symbolic manner. So this is the concept of the recording techniques, and we are applying the concept of method study in the industry. Means we are applying this particular recording techniques in the industry, through which you will get the detailed information about wherever the unnecessary operations are present, that all the unnecessary operations can be eliminated. Whatever the unnecessary effective time is there, that ineffective time can be eliminated by using this particular recording techniques. Also, whatever the backtracking is taking place, that means whatever the repetitive movements are taking place, that repetitive movements are also recorded by using this particular recording technique. Means you will get the information. Now for this operation, some repetitive movements are there. For this operation, some unnecessary operations are there. So all these unnecessary operations, all that repetitive movements can be recorded by using this particular recording technique, and afterwards we have to go for the modification in that particular process. But for the modification, we have to get some data. We have to go for some analysis. Such types of the analysis will be carried out by using this particular recording techniques. So now, one by one, we will start with this particular recording techniques. So first of all, we will discuss about some of the symbols. So whatever the symbols are used to represent the sum of the operations. So method study symbols for recording the facts. So first of all, we will discuss about the symbols, which types of the symbols are used for the which types of the operations. Okay. Now this is the one figure in front of you. So while converting the raw material into the finished goods, we are using the number of operations. Maybe we are using the piecing operation, we are using the drilling operation, we are using the boring, champering, threading, milling, shaping. So many operations are there which will be performed by using the machine only. So whatever the operations we are performing, that operations can be performed by using the machines only. Maybe lathe machine is there, drilling machine is there, milling machine is there, CNC is there, VMC is there. All these particular machines perform the operation on that particular job, and that operation can be represented by using the first symbol, which is represented by the circle. The circle represents the operation performed on that particular raw material. If I have to show the drilling operation, that drilling operation can be represented by using this particular circle. Means it is the symbol which is used to represent the operations performed on that particular raw material. Any one operation, maybe drilling, piecing, champering, threading, boring, or any some other operations, all such types of operations can be represented by this particular symbol, which is represented by the circle. Then second, inspection. Inspection means we have to checking of that particular product. For example, if I have performed the turning operation, after turning operation, if I have to measure the diameter, then for the diameter purpose, I have to take that particular vernier, and by using that particular vernier, I have to check the diameter of that particular product. Means we have to go for the inspection. Sometimes the inspection can be carried out after performing all the operations. Sometimes the inspection can be carried out after performing all the operations, but sometimes some of the products are there in which if I will perform one operation, after performing one operation, immediately I have to go for the inspection. If I will go for the second operation, after finishing the second operation, again I have to go for the inspection. So such types of the operations we are doing on the lathe machine. So on the lathe machine, what we are doing? We are holding the job in the job. We are performing the turning operation. For example, your diameter is initially diameter of the job is the 50 mm, and we have to reduce that particular diameter up to the 40 mm. So what we are doing initially, we are doing the turning operation. If the first operation is performed, again we are taking the vernier and we are measuring the diameter, and your diameter is from 50 mm to 45 mm. Again I have to reduce the diameter up to 5 mm. Again I will perform the turning operation. Again I will check the that diameter. If that diameter is 40 mm, then I will stop that particular operation. That means some of the products are there in which inspection can be carried out after performing all the operations. But if you take the example of lathe machine, in case of a lathe, if one operation is finished, immediately we have to go for the inspection. So such types of the inspection can be represented by this particular second symbol, which is called as a one rectangle or the square. This rectangle or the square, it represents the inspection taking place in the operating processes. So that inspection can be represented by using this particular second symbol, which is called as a rectangle or the square. Then third symbol, it represents the arrow. Arrow means transportation. If your raw material or if your product is moving from one workstation or from one machine to the second machine, then that movement can be represented by using this particular arrow. This arrow represents the transportation. So such types of the arrows are displayed in the industry. That means from this workstation, your product is moving to this particular machine. From this machine, it is moving to this machine. From this machine, it is moving to this machine. So like that, arrows are represented in the industry. So through this particular arrows, you will get the proper direction or the proper movement of your material from one machine to the second, from second to third, third to fourth, like that. So all this particular transportation, it can be represented by using the third symbol, which is called as a arrow. Then the fourth symbol is delay. Delay, that symbol is also represented by the capital D. You can see here. The symbol is also developed in the form of capital D. Delay means what happens sometimes if during operation process, if the tool will get break, if the coolant is finished, if your oil is finished, or maybe some accident is happening in the industry, at that time you have to stop your operation. If your operation is stopped, means we can say that there is a delay in the operation process. Or sometimes what happens, if you take the example of lathe machine, whatever the tool is provided to you on the lathe machine, by using that particular tool, we can perform the piecing operation, we can perform the turning operations, we are performing the champering operations. But if I have to perform the threading operations, so what I have to do? I have to remove that particular my old tool and I have to attach the new tool which is used for the threading operation. Means what I have done, to change that particular tool, some amount of time is required or some delay is happen in that particular operation process. So that particular delay in the operation process can be represented by this particular fourth symbol, which will represent the capital D. So the delay can be implemented or delay can be occurs due to the number of operations. Maybe delay due to the changing the tools, delay due to the changing the oil, delay due to the changing the coolant, delay due to the your tool is bricked. So many unnecessary operations, so many unnecessary tasks are generated in that particular machine. So such types of the delay in the operation process, it can be represented by using the fourth symbol, which represents the capital D. And the last symbol, which is called as a storage. Now, if your product is ready, all the operations are performed, and if I have to take that particular product from that workstation to the storage device, at that time that storage can be represented by using this particular fifth symbol, which will be represented by the inverted triangle. Otherwise our triangle will be like that. Our triangle will be like that. But whatever the storage is there, storage means I have to store that particular product from that particular workstation to the storage device. At that time, that storage can be represented by using this particular fifth symbol, which will be represented by the inverted triangle. So these are the 5 symbols which we have to use in that particular recording techniques. If I have to represent the operations, any operation which will be performed by the any machine, that operation can be represented by this particular circle. Inspection means checking the dimensions, checking the job, it can be represented by this particular rectangle. Transportation, movement of job or movement of material from one machine to the another machine, from second to third, it can be represented by this particular arrow. Then delay means changing the tool, breakage of tool, changing the oil, changing the coolant. So such types of the delays are happening in the operation process. That delays are also represented by this particular fourth symbol as a capital D. And once your product is ready and we have to move that particular product from that particular machine to the storage device, that storage can be represented by this particular last symbol, which is called as a inverted triangle. So you have to keep all these particular symbols in your mind, because sometimes if any task is given to you, for example, now you have to perform the assembly of nut and bolt. to perform that particular assembly of nut and bolt, which types of the task we are performing, all that particular task we can represent it in this particular symbolic manner. So please keep in mind this particular symbols. Through this particular symbols, we have to develop some of the manufacturing processes in the form of symbolic manner. So operation O or the circle, inspection rectangle, transportation arrow, delay capital D, and storage inverted triangle. So like that you can keep in your mind, so it will be helpful for your further study. Okay, so these are the standard symbols which will be used in the method study for recording the facts. These are the 5 symbols which are used for recording the facts. Now we'll start with the first recording techniques, that is charts. Now we will start with the first recording techniques, which is called as a chart, and from that particular chart we'll start with the operation process chart. But before starting with the particular first type, we'll discuss about the chart. What is the use of that particular chart, and from that particular chart which type of information you will get. So the chart is one of the most popular method for recording the facts. Just now we have discussed recording the facts means if we are doing the operation, if we are doing the inspection, if we are doing the transportation, if there is any delay, if there is any storage. So all such types of the facts, it can be recorded by using this particular chart. That means whatever the charts we are discussing in that particular charts, we are using whatever these 5 symbols just now we have discussed, that 5 symbols we are going to use in that particular chart. So the chart is one of the most popular method which is used for recording the facts. In addition to that, it will give the adequate description of the activities. So whatever the activities we are performing on that particular raw material, all that particular activities can be recorded by using this particular chart. For example, for 5 minutes, if I am doing the operations, so that 5-minute operations can be recorded by using this particular chart. After the 5-minute operation, for the 10 minutes, if I am doing the inspection of that particular job, so that 10-minute inspection is also recorded by using that particular chart. After the 10 minutes, if I have to change the tool of that particular machine, means the delay is happen, and for that particular delay, if 5 minutes are required to change that particular tool, that 5 minutes are also recorded by using this particular chart. That means whatever the task, whatever the fact we are performing on that particular material, all that particular task, it can be recorded in the descriptive manner. Also, that chart will give the proposed method or the proposed work. Whatever the task we are performing for the next 10 minutes, whatever the task, whatever the operations we are performing on that particular machines, all that particular detailed structure, how many times I am doing the operation, how many times I am doing the inspection, how many times the transportation is taking place. So all that particular detailed nature, it can be represented by using that particular chart. In addition to that, whatever the time is required to perform each operation, time required for the inspection, time required for the delay, time required for the transportation, time required for the storage, all such time is also recorded by using this particular chart. In addition to that, how much amount of distance is traveled by that material from one machine to the another, from second to third. Similarly, how much distance is traveled by the worker from one machine to the second, second to third. All these times are also recorded by using this particular charts. In addition to that, who is performing that particular operation? Who is performing that particular operation? The name of that particular worker, date of that particular process is also represented by using this particular chart recording techniques. Who is performing? Name of that particular worker. On which date that operation is performed, that date is also represented by using this particular chart. So therefore, this chart is one of the most popular method which is used for recording the each and every fact. Whatever the raw material is converted into the finished goods, from that particular raw material up to the finished goods, whatever the movements are taking place by that particular material, whatever the movements are taking place by that particular equipment, and whatever the movements are taking place by that particular worker, all the movements, their important time, it can be recorded by using this particular chart. Therefore, it is the most popular method which is implemented in the industry for recording the facts. Okay, and now we'll start with the first fact, that is operation process chart. So the operation process chart, it is also called as a outline process chart. The name itself suggests. Operation process chart means whatever the operations we are performing to convert the raw material into the finished goods, all those operations are represented by the operation process chart, and it is also called as a outline process chart. Outline means whatever the operations we are performing, outline of that particular operation is represented in the form of graphical form or in the form of graphical symbol. Means whatever operations we are performing to convert the raw material into the finished goods, the outline of that particular operation, if it is represented in the graphical form, therefore this chart is also called as a outline process chart. Also, it represents the entry point of the material as well as exit point of the material. Entry point means from which operation your material will start doing the operation, or it will be converted from the finished goods. So entry point of that particular material and the exit point is also represented by this particular operation process chart. Therefore, here I have written in operation process chart, major activities, entry points of that particular material are recorded in the graphical representation of operation and inspection in the process. Please keep in mind that through this particular operation process charts only we can represent the operation carried out on that particular raw material and inspection carried out in the process. We have discussed the 5 symbols: operation, inspection, delay, transportation, and the storage. But out of that particular 5 symbols, whatever the 2 tasks are there, operation and the inspection. So by using the operation process chart only we can represent the number of operations carried out on that particular raw material and number of inspection process carried out on that particular material. That means storage, delay, and transportation. It will cannot be represented by using the operation process charts. Only it will give the outline of the process. Outline means which type of operations we are performing on that particular raw material, and after performing each operation, which type of inspections processes we are performing on that particular material. Only these 2 types of information can be possible by using this particular operation process charts. In addition to that, it will give the overall picture of that particular process. Overall picture means after drilling operation, we have to go for the boring. After boring operations, we have to go for the facing. After the facing operations, we have to go for the threading. So like that, overall picture of the operation is also represented by the operation process chart. In addition to that, it will represent the sequence of operation. If you take the example of lathe, on the lathe, first of all, we have to go for the facing. After that, we have to go for the turning operation. After turning, we have to go for again some turning operation to reduce the diameter. After that, we have to go for some champering operations. After that, we have to go for the gluing operation. That means sequence of operation is set. So that sequence of operation is also represented by using this particular operation process chart. That means it will give the overall picture of the process. Overall picture in the sense how many operations are performing and how many inspections are performing. That means it represents the overall picture. In addition to that, it represents the sequence of operation also. Then third point, it is represented in the vertical straight line. So whatever the operations are performed, drilling, then boring, then champering, then facing. So all that particular operations are represented in the vertical line only. And for each and every operation, the numbering will be given. For each and every operation, the numbering will be given, time will be given, and name of operation is also given. So whatever the symbol is there, for example, if I have to perform the drilling operation. So this is the symbol for the drilling operation, which is represented by O or the circle. So for this particular operation at the center, I have to give the number. That means it is operation number 1. Okay. To the right side of this particular symbol, I have to represent the name of the operation. For example, if I will, I am using the turning operation. So at the right side, I have to give the name turning operation. And for that particular turning, if the 5 minutes are required, at the left side, I will represent the time. Means at the center of that particular symbol, the operation number is given. At the right side of that particular symbol, which operation we are performing, turning, facing, drilling, gluing, the name of that particular operation is represented at the right side, and the time required to perform that particular operation, it will be represented at the left side. So like that, you have to represent the operations in the vertical manner. But this operation process chart will not give the information that place of the work and who is performing it. At which place these operations and the inspections are going on, whether it is going on in the design department, or whether it is going in the production department, or whether it is going in the manufacturing department, such types of the information will not be achievable in this particular operation process chart. And who is performing that operation, whether skilled operator is performing, whether unskilled operator is performing, whether supervisor is performing, that information is also not possible to get from this particular operation process chart. Only you will get the information of overall picture of the process, which types of the operations we are performing, which types of the inspections we are performing. Also, you will get the information about proper sequence of the operations. All such types of the overall picture sequence of operations can be recorded by using this particular operation process chart. Therefore, it is called as a outline process chart. But where these operations are going on, where this inspection is going on, who is performing that operation, who is doing the inspection, such types of the information will not be possible in this particular operation process chart. Means this is the disadvantage, or this is the limitation of the operation process chart. Now we'll discuss about this particular operation process chart for one of the examples. Now you can see operation process chart. What example I have considered? Manufacturing of axle and the nut. Now you know about the axle and you know about the nut. Okay, so what I have to do? I have to go for the manufacturing of nut and the manufacturing of the axle. So that operations I have to perform, and after the manufacturing of that nut and axle, at the end I have to go for the assembly. But what is our requirement? Here at the left side, the manufacturing process of the axle is represented. At the right side, the manufacturing process of the nut is represented. So I will first of all, I will start with the manufacturing of the nut. So this is the vertical operation process. This is the vertical operation process which represents the manufacturing operations or operations and the inspections carried out during the nut manufacturing. So initially you will get the raw material having diameter 15 mm. It is represented. Okay. Initially whatever the raw material is given, it is 15 mm. Now first operation, you can see first operation is represented by the circle. So one number is given at the center. At the right side, which operation we are performing? Facing. How much amount of time is required? 2 minutes. So 2 minutes are represented at the left side of the symbol, and type of operation is represented at the right side of the symbol. Then second operation, which it is represented by rectangle, means after facing operations we have to go for the inspection. Initially I have performed the facing operation, then I have to check whether my length is reduced or not. Means second operation is performed as the inspection. Again at the center point only one is there, because this is the first inspection operation. Therefore at the center point there is only one. At the right side, inspection is given. Need not required to give the detailed inspection, whether we are measuring by using the vernier or gauges, not required. Only if I will write out the inspection, it will be sufficient. How much amount of time is required for the inspection? 1 minute. It is represented at the left side of the symbol. Then after the inspection, again I am doing the second operation. Operation is represented by the circle. Therefore, at the center point, now the second symbol is there. You can give after first operation fishing, we are performing the second operation as a threading. So the second operation is represented in the form of circle, and at the center we have written the 2. That 2 represents the second operation is performed on the raw material. At the right side, which operation? Threading. How much time? 5 minutes are required for the threading operation. Again for threading, again we have to go for the inspection. So that means second times we have to go for the inspection. Therefore, we have taken the rectangle. At the center point, I have written the 2 because already first inspection we have performed after the fishing operation. After threading operation, again we have to go for the inspection. Therefore, I have drawn the symbol of rectangle. At the center point, I have written the second number, means second inspection is there. At the right side, inspection word is written. At the left side, how much amount of time is required for the second inspection? 1 minute is required. Okay. Then next operation, again next operation is represented by the circle. Which operation is performed? Champering. For how much amount of time? 2 minutes. And as the champering is one of the type of operation, therefore this champering is represented by the circle. And at the center, I have written the 3. That means to convert the raw material into the nut. To convert the raw material into the nut, 3 operations we have performed. One is the facing, another is the threading, and third one is the champering. And all the 3 operations are represented by the circle. Facing is the 1, therefore 1 is written. Threading is the 2, therefore 2 is written. Champering is the 3, therefore 3 is written. But only 2 times inspection will be taking place. Inspection number 1 after the facing operation. Inspection number 2 after the threading operation. After champering, inspection is not required. We are doing the champering means we are removing the whatever the sharp edges are present in the job. That sharp edges we are removing by using that particular champering operation. Therefore, after champering, inspection is not required. Therefore, after champering operation, the inspection operation is not represented. That means to convert the raw material into the nut, 3 operations we have to perform and 2 times we have to go for the inspection. Similarly, at the left side, whatever this vertical line is represented, it represents the total manufacturing process and total inspections of that particular axle. Now nut is prepared. Now we have to go for the axle. For preparing the axle, whatever the raw material is given, its diameter is 10 mm. At the top, here it is written, diameter is 10 mm. Now, once the manufacturing of the nut is over, by using the same machine, if to manufacture this particular nut and axle, if I have used only one machine, for example, lathe machine, so what we'll do? After the manufacturing of the nut, I will remove that particular nut from that particular chuck and I will insert the new material for manufacturing of the axle. That means machine is same. Therefore, while manufacturing this particular axle, first operation is performed as a turning. You can see the first operation will be performed as a turning, and that operation is represented by the circle. But at the center point, what is the number? 4 number is given. Why? Because we are manufacturing that particular nut and axle by using the same machine only. But for the manufacturing of nut, initially I have performed the facing, threading, and the champering. That means 3 operations are performed by using the same lathe machine. Now I have to perform the 4th operation as a turning, but it will be performed on that particular second material, that is raw material having diameter 10. Therefore, here I have not used the number as a 1. For the manufacturing of axle, if I will use the second machine, then that operation will be start with the 1, 2, 3, 4, 5, 6 like that. But I am manufacturing the nut and axle by using the same machine. Therefore, after the manufacturing of nut and on the nut, which last operation we have performed? We have performed the champering operation and its number is 3. Once champering is over,
I will remove that particular nut from the lathe machine. I will insert the new raw material in the chuck, and for that new raw material, I am performing the turning operation. Therefore, fourth number is given at the center, and at the left side, 2 minutes is given. After the turning, again inspection is there. Again, 1 minute time is required. But what is the number is given for the inspection? Third number is given, because for manufacturing of nut, already after the facing operation, one inspection is carried out. After the threading operation, another inspection is carried out by using the same setup. Therefore, in the axle manufacturing, whatever the inspection is carried out after the turning operation, that inspection is represented by the third number, because we are using the same machine. Then after the inspection, machining of head. Machining of head, that means one operation we are doing, that operation is represented by the fifth number at the center. At the left side, 5 minutes are required for machining the head. After machining, again we went for the inspection, so that inspection is represented by the fourth number. At the left side, 1 minute is required. After inspection, again we went for the threading of the axle. Nut मध्ये पण आपण threading केलेला आहे, axle मध्ये पण again we have to go for the threading. That operation is represented by the sixth number. 5 minutes are required. Again we have to go for the inspection. Inspection is taking place 5 times, therefore 5 number is given. Again 1 minute is required. Again, in case of a axle also, if I have to remove some sharp edges, again we have to go for the champering operation, and that champering operation is represented by the 7 number or circle. Operation means circle, center point 7, and the 2 minutes are required. But after the champering operation, inspection is not required, because only we are removing the sharp edges. So after the champering, the inspection is not required. That means by using this particular right process, nut is manufactured. By using this particular left manufacturing process, axle is manufactured. But if you look at this particular both the charts, only two symbols are present. One is a circle, means operation, and second is a rectangle, means inspection. Means in case of a operation process chart, only the operations and the inspection can be represented. Other storage, delay, transportation, it will not be represented in this particular operation process chart or the outline process chart. So whatever this particular right chart is there, it represents the manufacturing process of the nut and their inspection, and whatever this particular left chart is there, that left chart represents the manufacturing process of the axle and their inspection. But both the nuts and the axles are manufactured by the same machine, therefore the sequence of operation is not changed. Means 3 operations are performed on the nut, 2 inspections are performed on the nut, and remaining operations, total how many operations are performed? Total you can see 7 operations are performed. Out of that, 3 operations are performed on the nut, and remaining 4 operations are performed on the axle. Okay, how many inspections are performed? Total 5 inspections are performed. Out of that 5, 2 inspections will be carried out on the nut, and remaining 3 inspections will be carried out on that particular axle. And once nut is ready, axle is ready, at the end we are doing the assembly. At the bottom side you can see here, at the end, this chart of the nut and the chart of the axle, they are combined here. They are combined here, and after that we are doing the assembly. Assembly is also one of the type of operation. Assembly is also one of the type of the operation. Therefore, that assembly is also represented by this particular circle, and at the center it is written as a 8. Means after last 7th champering operation, we are doing the assembly, and that assembly is represented by the 8. That means circle is there. At the right side, assembly is represented, and how much time is required for the assembly? For example, 10 minutes. It is represented at the left side. Again, after the assembly, if again I have to go for the final inspection, again inspection is represented by the rectangle. In case of an axle, the last inspection is represented by the 5th number. But after the assembly, if again I have to go for the final inspection, that inspection is represented by the rectangle. Therefore, at the center, it is written as a sixth. That means final inspection is represented by the sixth number. At the right side, final inspection, and at the left side, final inspection will be carried out for the 1 minute only. So through this particular chart, you will get the overall picture of that particular manufacturing of axle and nut. In addition to that, you will get the sequence of operation. Sequence of operation means initially we have manufactured the nut. For the nut, you will get the sequence of operation. After the manufacturing of nut, we have manufactured the axle. To manufacture that particular axle, what is the sequence of operation? That sequence is also represented by this particular operation process chart. And after the manufacturing of nut and axle, how the assembly will be taking place and how the final inspection will be taking place. That means from this particular chart, you will get overall picture of that particular manufacturing process and their assembly. In addition to that, you will get the information of sequence of operation. But through this particular chart, you will not get the information where these operations are performed, whether these operations are performed in the design department or manufacturing department or R&D department or the inspection department. That location, it is not possible to get from this particular operation process chart. In addition to that, who is performing that operation? Who is doing that particular inspection? The name of that particular operator also not possible to get from this particular operation process chart. Only you will get the overall picture and only you will get the sequence of operation. Therefore, this chart is called as a outline process chart. And which type of information you will not get? Where it is going on and who is performing means this is the major limitation of the operation process chart. That limitation can be eliminated in the next types of the charts that we will discuss in the next lecture. So this is about the operation process chart. That's type number 1 from the chart, operation process chart, which is called as a outline process chart, which represents the overall picture of the operations and the sequence of the operations. Okay, so with this, today we will stop here. The remaining part we will take in the next lecture.